Question 13. A closed tube has one end sealed and the other end open. A sound wave with a frequency of 740 Hz is produced inside the tube. The speed of sound in the medium is 340 meters per second. What is the length of the tube? This is a problem relating to resonance and standing waves in air columns. Let us recall what we know. For a tube that is closed at one end and open at the other, the fundamental or first mode of vibration occurs when the length of the tube is equal to 1/4 of the wavelength. This is the smallest standing wave pattern possible in a one-end closed pipe. We also know that wave speed, frequency, and wavelength are related by the equation. Wave speed equals frequency multiplied by wavelength. Now let us think through the solution step by step. First, identify the quantities given. The speed of sound is 340 meters per second. The frequency of the sound wave is 740 Hz. For a tube closed at one end, the relationship between tube length and wavelength of the fundamental note is tube length equals wavelength divided by 4. Next, we calculate the wavelength of the sound wave. From the wave equation, wavelength equals wave speed divided by frequency. Substituting the given values gives wavelength equals 340 divided by 740 meters. This gives a wavelength of approximately 0.459 meters. Now we determine the length of the tube. Since the tube length equals 1/4 of the wavelength, we divide the wavelength by 4. So the tube length equals 0.459 divided by 4 meters. This gives approximately 0.1149 meters. Converting this into centimeters gives approximately 11.5 centimeters. So the length of the tube is about 11.5 centimeters. This is our final answer. What did we do? First, we used the wave equation to determine the wavelength of the sound wave from the given speed and frequency. Then we applied the standing wave condition for a tube closed at one end, which states that the fundamental length equals 1/4 of the wavelength. Finally, we substituted the calculated wavelength into this relation to obtain the tube length. Now let us consider a common misconception. Students often mix up the formulas for open tubes and closed tubes. A tube closed at one end does not use the half wavelength relation used for open tubes. Instead, the fundamental mode follows the quarter wavelength relation, and only odd harmonics are present, such as 1/4 wavelength, 3/4 wavelength, 5/4 wavelength, and so on. We can now summarize in closing. A closed tube has a node at the closed end and an antinode at the open end, so its fundamental wavelength is 4 times the tube length. The speed of a sound wave is given by the relation wave speed equals frequency multiplied by wavelength.